Today what we're going to be doing is simplifying radical expressions, or simplifying square roots, cube roots, and so on. So remember when we did this before, if we were in square root land or simplifying square roots, we wanted to divide the number underneath the square root by those perfect squares. But if we were in cube root land, we'd want to divide the number underneath the radical symbol by our perfect thirds. And we can refer to our chart as we need it. Now, once we simplify radicals, if they are like radicals, we can combine them. So if we look at example number 1, we have 2 times the square root of 48 minus 3 times the square root of 27. Those are not the same radicals, so we can't combine them. But what we're going to do is we're going to simplify the square root of 48. So we can do that. So when we simplify radicals like this, we always want to make sure we remember this 2 out in front. And you want to try to divide that number 48 by the biggest perfect square. Okay, so you might say, well, what about 4? If you do 48 divided by 4, that will give you 12. Well, is there a bigger number that we could do? And there is. We can do the square root of 16 times the square root of 3. Now, if you didn't see 16 times 3 is equal to 48, you could do 4 and 12, but then you'd have to simplify the square root of 12. And we have minus 3, and we can break up the square root of 27 into 9 times 3. Then we have 2 times the square root of 16 is 4 times the square root of 3. So this gives us 8 times the square root of 3 minus 3 from right here times the square root of 9, which is also 3, and then times that square root of 3 that we had as well. So then this part can be simplified to minus 9 times the square root of 3. Well, now that our radicals are exactly the same, this is going to equal negative 1 times the square root of 3, or just negative square root of 3. So we weren't able to do that, to combine these, until we got those radicals exactly the same. Now if you look at number 2 over here, we are in cube root land. So when I look at 250 and 54, instead of trying to divide it by 4, 9, 16, 25, and so on, I want to use those third roots. We have 125 times 2. Now I say, well, what do we do with this x? Well, we'll talk more about this tomorrow, but you might remember that in order for a variable to get out of the square root or the cube root or whatever radical we are in, your variable needs an exponent that is equal to or bigger than your index. So if this was x to the third power, we could bring that out. But if it was x squared, we couldn't bring that out. X to the fourth, we could bring that out, but we would also have a leftover on the inside. Like I said, we're going to do more of that tomorrow. But for now, we can't do anything with that x, so it's just going to stay inside. Minus, well, let's break up 54. 54, if we divide that by 27, because 27 is a perfect cube, then we are left with 2x, because 54 divided by 27 is 2. The cube root of 125 is 5. So we have 5 times the third root of 2x. I'm sorry, let me go back and fix those. Cube root, cube root, cube root, cube root, and this would also be the cube root, minus the cube root of 27 is 3. So we have 3 times the cube root of 2x. Now that these are exactly the same, we can combine them. Now, if one of them was the square root of 2x and the other one was the cube root of 2x, we could not combine them. It has to be exactly the same. So then this is going to be 2 times the cube root of 2x as your final answer. All right, now this one I want you guys to try. There's 3 terms that you have to simplify. And remember, because we have those variables and they're all the exponents are 1, we don't need to do anything with them. We can just leave them under the radical. So go ahead, pause the video, try this, and then once you're done, we can go over this. All right, so this is your answer. Down here, we could not combine 4 times the third root of 2z and 4 times the third root of 5z because 2z and 5z are not the same thing. So they just have to be left separate like that. That would be your final answer. The next thing we're going to talk about is rationalizing the denominator. We talked about this again last year that we can't have the square root in the denominator. And we said, well, to get rid of that, we multiply the numerator and denominator by whatever radical I need to get rid of the radical in the denominator. So in this instance, if I divide the top and bottom by the square root of 2, the numerator becomes 6 times the square root of 2 over 5 times the square root of 4. Now, yes, you're going to get to the point where you can just recognize, okay, the square root of 2 times the square root of 2 is 2, times 5 is 10. That's okay, but I'm just showing you each of these steps. So now we have 6 times the square root of 2 over 5 times 2. So 6 over the square root of 2 over 10. We can reduce those numerals, divide the top and bottom by 2, and we get 3 times the square root of 2 over 5. We can't simplify the square root of 2 any further, so that would be our final answer. Then number 2, well, the square root of 32 is in the denominator, and yes, we can simplify that. You could simplify that first, or you could multiply the numerator and denominator by the square root of 32 and then simplify that after you multiply and divide out any common factors. Either way is okay. It might be, and again, depending on what you're given, it might be easier to simplify the radical first, or to multiply by or rationalize the denominator first. I'm going to rationalize the denominator first. So 32 can be written as 16 times the square root of 2. So then that gives us 7 over 4 times the square root of 2. Okay, so now I'm going to multiply the top and bottom by the square root of 2. That leaves us with 7 times the square root of 2 over 4 times 2, which is 8. So that would be our final answer for that one. Now, like I said, if you would have multiplied the numerator and the denominator by the square root of 32, then you would have had to simplify the square root of 32 that was in the numerator and then simplify the fraction afterwards, and it would reduce down to this. All right, so the number 3, what we have here is we have more stuff in the denominator, and we can't just multiply by the square root of 5 because we have that minus 3 there. So we're going to multiply the top and bottom by what is called the conjugate. And like we've been doing so far this year, we've talked about these things before. We've talked about the conjugate. The conjugate is the exact same thing as the denominator, but we change the sign, either from negative to positive or positive to negative. So we're going to multiply the numerator and denominator by 5, the square root of 5 plus 3. Now the reason we do that is that way in the denominator when we FOIL, because these are parentheses and we have two things here, we're going to FOIL the denominator, and you're going to see that our middle terms are going to cancel out, so that way we have no more radicals. So I'm going to show it the longer way first, and then go back and show you the shortcut, and then just do the shortcut from now on. Okay, so the numerator, we distribute the 12 to both things. So we have 12 times the square root of 5 plus 36 over the square root of 5 times the square root of 5 is the square root of 25. Negative 3 times the square root of 5 is negative 3 times the square root of 5. Positive 5 times, if positive square root of 5 times positive 3 is positive square root of 3 times the square root of 5. And then negative 3 times 3 is negative 9. So you see right here, negative 3 square root of 5, positive square root of 3, positive 3 times square root of 5, those would cancel. Well, the square root of 25 is 5. So if we start rewriting this, minus 9. Okay. I'm going to rewrite this with the 36 up front. That's just the proper way to write it. 5 minus 9 is negative 4. Now, we can simplify this a little bit further because all of the numbers outside the square root are divisible by 4, or a negative 4. So we're going to divide everything by negative 4 to make our denominator 1. 36 divided by negative 4 is negative 9. And then 12 divided by negative 4 is negative 3. And the square root of 5 stays just like that. We're not dividing that by negative 4 as well. So then this would be your final answer. Now going back to the conjugate part, look at, we could have just done square root of 5 times the square root of 5, square root of 25, and negative 3 times 3, negative 9. We could just take the first and the last terms of our parentheses and multiply those and forget about all the inner stuff, and that would give us our answer down here. So number 4, we're going to do it that way. It'll save us a little bit of time to multiply top and bottom by 2 minus the square root of 5 over 2 minus the square root of 5. Again, that numerator, we distribute that 6 to both things, so 12 minus 6 times the square root of 5. But in the denominator, I'm only going to multiply 2 times 2. And then positive square root of 5 times negative square root of 5, that's going to be negative square root of 25, which is going to be just negative 5. Now, I want to clarify that I wasn't saying the square root of negative 25. It would be negative square root of 25, like that, because you'd have 5 times 5 was 25, and then that negative in front. So I just wanted to clarify that first. Okay, so now we have 12 minus 6 times the square root of 5 over 4 minus 5, which is negative 1. Now, we don't need to write divided by negative 1. We can just deal with that by changing these signs. So this would be our final answer. Now this last one, say, oh my gosh, there's two radicals. How do I do that? The exact same way. We still have a conjugate. It'll be 2 times the square root of 5 plus the square root of 3. So 2 square root of 5 plus the square root of 3. Because we can have square roots in the numerator. That's okay. That doesn't matter if we have 100 square roots or radicals in the numerator. As long as they're not in the denominator, it's okay. So distribute this 5. So we have, 10. 5 times 2 is 10. So we have 10 times the square root of 5 plus 5 times the square root of 3. Now, if we could simplify those radicals, we would want to see if we could combine them. But because we have the square root of 5, square root of 3, those are not like terms. They're not. You can't simplify them. We leave it just like that. Now the denominator, because those are conjugates, we can multiply these. So 2 times the square root of 5 times 2 times the square root of 5. That is going to be 4 times the square root of 25. Because you multiply the numbers outside together and the numbers inside together. And then we have negative square root of 9. Now, like I said in the previous problem, you could just simplify those in your head, but I wanted to show you separately 4 on the outside, and then the square root of 25 was stuck on the inside. So now we have 10 square root of 5 plus 5 square root of 3 over the square root of 5 is, square root of 25 is 5 times 4 is 20 minus 3. So now that will get us to 10 times the square root of 5 plus 5 times the square root of 3 all over 17. And we check and say, can we simplify any of these radicals? Nope. Can we simplify any of the numbers? Can we divide 10, 5, and 17 by the same number to simplify those? Nope, we can't. So this is our final answer. All right, so that's it for simplifying radicals when we're dealing with just numerals, just numbers. Tomorrow we're going to deal with simplifying radicals that have variables in them and the differences for those. So thanks for watching. Make sure to like the video and subscribe.